Okay, we're ready to begin. As it says, the normal approximation to the binomial distribution. This will correspond to assignment number 19. All right, what a beautiful spring day. The Royals are in first place. I hope you all are doing well. You all take care of yourselves and your families. So let's get after it. So we've talked about the binomial distribution when we did assignment 15. And in fact, example number 1 here will be a quick review of that. So we have a basketball player, Mario. He's going to shoot 5 shots. You guys should be familiar with this question because we did this one on, again, assignment 15. So if you recall, this would be considered a binomial experiment because each time Mario takes a shot, he either hits it or misses it. We're talking about hitting a shot, hitting shots. What's the probability of the 5 that he'll hit at least 3? So like we talked about on assignment 15, the variable x, the number of hits, could be anywhere from 0 to 5, and each one has a probability, okay? And we know that all those probabilities add up to 1, which is the decimal equivalent to 100%. So what we're looking at here, what's the probability he'll hit at least 3? So wouldn't these be the numbers where he would hit at least 3? He can hit 3 or 4 or all 5. So that's as we talked about on assignment 15. This is so assignment 15. But it's going to lead us into this new concept here in a minute. All right, so as you might recall, we identify the fact that n, the number of trials, is 5. Mario's shooting 5 shots. And p, the probability of success, which is defined to be hitting a shot, all right, hit, and it says he's an 80% shooter, and therefore his failure would be 20%. We've done this question. In fact, we did this exact question on assignment 15. So this, again, would indeed be a flashback, all right? All right, so anyway, so the way we would set this up would be the probability that the number of hits is at least 3. So wouldn't that be greater than or equal to 3? All right, and in this scenario, a couple of things. That's not too many numbers. This is assignment 15 going on again, isn't it? So the point would be, why don't we set up the probability for hitting 3 of those shots? So you might recall we said, Mario, I'll give you 5 shots. You can choose any 3 to hit, which means you're going to succeed on 3 of them, and you're going to fail on 2 of them. And then that would be the setup for this particular probability for 3, wouldn't it? You go, check. So you remember, you identify the numbers that satisfy the question. So at least 3. 3, 4, 5. All right. Or plus, what'd you call me? Or he could hit 4. All right. Hey, Mario, I'm going to give you 5 shots. You can choose 4 to hit. I don't care what order. That's why this, again, I want to remind you, is a combination, that calculator function that we practiced. You're going to succeed on 4 shots, therefore you'll fail on 1. Crunch, 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 you get that number, and that would be this one. We've done this exact question on assignment 15. All right, and then the probability of hitting all 5 shots. Hey Mario, I'm going to give you 5 shots. You can choose 5 to hit, which means you're going to succeed on 5 of them, and therefore fail on 0. Crunch, 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 put it in the calculator. So we did this, as I mentioned. This is an old example, and we're going to use it to bridge into the new concept here. And so, as a matter of fact, we did the entire probability distribution back on assignment number 15. But this probability right here turns out to be 0.2048. That's the probability of hitting 3 of those shots. And then 0.4096 is the probability of hitting 4 shots. And remember, we add these. And then the probability of hitting all 5 shots turns out to be 0.32768. And then you add those up because he'll either hit 3 shots or 4 shots or 5 shots, these entries in that table that we built. And that total is 0.94208. So there's roughly a 94% probability that Mario will hit at least 3 of those shots. So you're probably thinking there, well, Mr. Cinderella, that's assignment 15. Why are you doing this again? Well, here's the question. that will lead us into example number 2. That was a relatively small range of numbers, right? 3, 4, 5. Not a big deal. Set up the formula for those 3 numbers and add them together. But what if Mario shoots a lot more shots? Let's say he shoots 100 shots, okay? Then he could have anywhere from 0 to 100 hits. And suppose the range of numbers described in the question was way more than just 3 numbers. That would be a very cumbersome process right there. So we're about to transition into example 2, where we'll address that very issue. So stay tuned.